Okay, listen carefully. Oh, word problems. I hate word problems. I can't do word problems. Oh my gosh, word problems are so hard. Yeah, I'm just not going to do those. We've heard it all, people. We're going to try to take these and break them down, and you're going to use these notes while you're doing your homework because they're going to look a lot alike, okay? So here we go. Boom. Jack is thinking of a number. Oh, yeah, you know what? I don't start at the beginning. I start at the end. The last thing says write an equation and find Jack's number. That tells me I am looking for Jack's number. So I'm going to let my variable be J. You can let it be X, but I like J. Jack's number. Guess what my name is? Oh, it's Jackie. I love this problem. Jack's number. Now, the next thing we're going to do is read each sentence. Each sentence tells us something very interesting. Jack is thinking of a number. What does that tell us? That tells us Jack is kind of a boring guy. He's sitting around thinking of numbers. Actually, it tells us he's a real mushroom, a fun guy. He is a fun guy because he's thinking about math. Love it, love it, love it. The next thing we're going to do is look for the word is. Write this down. When you look for the word is, that is your equal sign. Now, unfortunately, it's not always that blatant. It's not always that obvious. Sometimes it's the verb. Cost. Cost is a verb. Sometimes it's are. That's plural is, was, past tense is. It's not set in stone, people. Otherwise, it would be really, really easy. You have to interpret. So is going to be your equal sign, and we have an is in the next sentence. 8 more than the product of 5, and the number is. Bingo, zingo, we've got an is. Is separates the left and the right side of the equal sign. So I'm going to put my equal sign. Now, the reason I put it way over to the right is look at all this stuff that's got to be at the left. And on the right, all I have is this cute little 93. So now I got to figure out how to write 8 more than the product of 5 and the number in math speak. Okay, because I don't know what that means. So if I interpret it into math, I'll understand it. So the first thing I'm looking for is a clue word. There are clue words that are going to tell you to add, subtract, multiply, and divide. So let's write down some of the clue words. More, that's a good one. I see it right there. For minus, you've got less. That's a good one. Multiplication, you've got of, per, all sorts of fun words. Divided by, yeah, we'll talk about that later. All right, so what am I looking for right here? I see more than. Now, here's the deal. More, if it comes with a than, so I'm going to write this in black because this is huge. Write this. I'm writing it huge. The word than, if you see bleh, than, that means start behind the word than and then move to the front. So what this is, as soon as I see with than, I'm going back here. I need to write an expression for the product of 5 and the number. Product is multiplication. So I want to multiply 5 and a number. So that's 5J. Remember I said J was Jack's number. More means plus. And how much more do I want? 8. So here's the deal. If I say you are 20 years more than my dog's age. Okay, first of all, that's a lie. I don't have a dog. Well, I do have a dog, but you're not 20 years more than my dog because my dog is 8. But anyway, in order to know how old you are, we first have to know how old the dog is, right? So that's why when we have the more than, when we're comparing something, we have to know the thing we're comparing it to first. So we have to do the second part first. Then we're just going to solve this the regular old way. We're just going to subtract 8, bada bing, bada boom. We're going to have 5J equals 85. We're going to divide by 5. And we're going to get J equals 17. We cannot stop there. On the I-STEP test, they want a complete sentence. So we're going to say Jack's number is 17. Okay? Jack's number is represented by all this stuff. There's our is, that's our equals, 17. Look at that. Boom! First one done. Jack is happy. Okay, number 2, Jill is thinking of a number. Oh, Jack and Jill. See, this is what they did while they were going up the hill to fetch a pail of water. They were thinking of numbers. So go to the end, write an equation, and find Jill's number. So J is going to equal Jill's number. I promise you people, I did not write these, but I like that they're all J's. I'm looking for the word is, remember. So Jill is thinking of a number. That just says she and Jack are playing a number game. 6 less than 2/3 of the number is, there's my is, get my left and my right. Again, lots of stuff, little. So put your is over here and it equals 14. Now, we're looking for the words. Remember 6 less than. Less is our minus, but than says start over here. Again, if I say you are 40 years less than my age, to find out how old you are, you have to know my age first and then take 40 away. By the way, I'm lying again. You are not 40 years, yes, less than my age. So we've got 2/3 of the number. Of is multiplication. There's your multiplication word. So 2/3 of the number, it's Jill's number, that's J, and we want 6 less than that. So we're going to add 6. I have 2/3 J equals 20. I'm going to multiply by 3/2. Off to the side, I can do 20 over 1 times 3 over 2. 2 goes into 2 once, into 20 10 times. So I get J is equal to 30. Because 3 times 10 is 30. So Jill's number is 30. Look over here, I thought it was 2. Nope, peace out. Done with that slide. Miss Gadget's car broke down on the turnpike. Oh, poor Miss Gadget. I have been there, people. It is really sad. Now, however, Miss Gadget's driving that car. Did she really think it wasn't going to break down on the turnpike? Come on, Miss Gadget. Acme Towing charged $30 plus $3 per mile to tow the car. Remember, we start at the end. If Miss Gadget paid $162, how far was the car towed? So we're going to let M equal the number of miles towed. Okay, how do I know it was miles? Because we charge per mile plus we're in America and we say miles. If we were doing this in England, we would say meters. Okay, but we're not doing it in England, although we could pretend we were doing it in England, but we're not. We're doing it in America. Here we go. So Miss Gadget's car broke down on the turnpike. That's actually a no duh when you look at her car, but it doesn't give us any math. Acme Towing charged $30. Okay, so here's Acme Towing's truck. Acme Towing. It's got the little thing, truck, okay? It comes to see Miss Gadget. She's wearing a skirt just so that I can, because I draw skirts better. Okay, Miss Gadget, automatically, she is going to have a bill that says $30 because they are going to charge her $30 just for showing up to tow her car. Then this part right here, this plus $3 per mile. So they hook her car, here's her car. They hook it up and they start towing, drive to their company. So it was $30 to start, and then here's the first mile, that cost her $3. Here's another mile, that cost her $3. Another mile, $3. Another mile, $3. Another mile, $3, blah, 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 until we get over here and her total bill is $162. Okay? So if you notice, Acme Towing charge, blah, 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 to tow the car. That's just telling us what the charge is. If she paid, that's our is this time. That's our verb. She paid $162. So we're going to start off with, she was charged $30. That's what the cost is no matter what. That's called the no matter what cost. Yeah, try to remember what that means. No matter what cost, plus $3. Now, it's only $3 if she only goes 1 mile. What if she was 17 miles? Then it's 3 plus 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 3. I did say it's 17 times. I screwed up on the last one, but I said it's 17 times, but the easier way to do it is to multiply 3 times each mile. So to solve this, we're going to subtract 30. We get 3m equals 132. We divide by 3 and we get m equals 44. Again, we want an answer in a sentence. So it was towed 44 miles. And one of the reasons I like m instead of x is, what does m stand for? M, miles. There we go. All right, let's move on. Brenda has $500 in her savings account. and that actually doesn't say that. It says bank account. Every week she withdraws $40 for expenses without making any deposits. How many weeks can she withdraw this money if she wants to maintain a balance of $200? So that last sentence does give us the question. It gives us, we have to look for it though. Without making any deposit, how many weeks can she withdraw? So let's W equal the number of weeks she withdraws. Okay, let's start right at the end of the sentence there so we can't fit it. Withdraw means she takes out, okay? So here's what's happening. Brenda, here's her savings account that's in this bank. She has $500 right now. See, there's her $500. Every week, so on week 1, she takes away $40. Week 2, she takes away $40. Week 3, she takes away $40. Week 4, she takes away $40. The question is, how many of these $40 can she take away and keep $200? So that's what we want. She wants her balance to be $200. So tell me what we are going to start with. She starts with 500. She withdraws. That means she subtracts out $40. She doesn't just take out 40. She takes it every week. So $40 times each week. Okay, this is the change. The start is 500. The change is 40 each week. So when we can't, oh my gosh, what is my word here? Solve this. We get negative 40W equals negative 300. And then we divide by negative 40. And we get W equals 7.5. Okay? So she can withdraw it. I don't even know how to say this. She can withdraw for 7.5 weeks. Now, here's the deal. Is she going to do it for that half a week? No. So what's she really going to do? She's really going to only do it for 7 weeks, right? Okay. So this is one of those questions I want you to ask your teacher. What is the answer here? The answer is really 7 weeks because she wants to keep a balance of 200. She's only doing it every week. So after the 8th week, she'll have less than 200. Tough question. Okay, consecutive integers. First of all, what does consecutive mean? It means numbers in counting. Are you writing this down? Yes, I am. Of course I am, Mrs. Evans. Numbers in counting order that are, I find this surface really hard to write on neatly. I am so sorry. That are right next to each other. So, for example, 1, 2, 3. Those are 3 consecutive digits. What if I keep on going? How about if I go all the way up here? 47, 48, 49. What if I go this way though? How about negative 12, negative 11, negative 10, okay? They're just in counting order, so if I was doing the number line, they'd be right next to each other. Consecutive even, so when we do our numbers, our first number's odd because we start with 1. Then the next one's even, then the next one's odd, then the next one's even, then the next one's odd, then the next one's even, and so on. So if I start with an even, how do I get to this one? I have to skip one. Get to this one, I have to skip one. Does that work if I'm doing odds? Just write down the same thing again. If I start with an odd, I have to skip one to get to the next odd. Skip one. So consecutive even and consecutive odd are actually the same thing. You're going to always skip one, okay? So this is going to be your lifesaver for these. Honestly, if you just can remember this and remember the drawing and how we went about this, you're going to be in good shape. First of all, every single time your first integer is x. This is always your first integer, okay? We don't know what that integer is, so we start with x. That's my first integer. Now, if I'm just doing consecutive integers and I want to go in order To get from this one to that one, what do I have to do mathematically? I add 1. Now here's the deal. I can't just keep saying plus 1, because here, what am I really doing? I'm adding 2. If I kept going, I would add 3, I would add 4, I would add 5. So to find your first integer, it's x plus 1, first is x, second is x plus 1, third is x plus 2. Okay? Now, consecutive, even, and odd, I'm going to change those and make them both green because they're the same. These two are going to be the exact same. When you're doing this, you're going to get your first integer, and it's going to be either an even integer or an odd. Then to get to the next one, remember we said you skip 1, so we can't just add 1, you have to add 2. Then to get to the next one, we skip again, so you're going to add 4. So this is the hardest thing, because this says odd. People want to say 1, 3, 5. Odd and even are the exact same thing. You're just skipping. So it's plus 2, plus 4 each time. All right? Rough stuff. Okay, so let's write down again x plus 1, x plus 2, even x plus 2, x plus 4, odd x plus 2, x plus 4. Find 3 consecutive integers. So I don't care about the even, I don't care about the odd, I'm looking at this. So I need 3 of them. My first one is x, so that's the first, right? My second one, I'm going to take whatever that number is and add 1. And for my third one, I'm going to take whatever the original number is and add 2. It says the sum. What does that mean I'm going to do with all of these? I'm going to add them. And then is, what did we say is my equals 42. So over here, I'm going to add x plus 1 plus x plus 2. So x plus x plus x is 3x, 1 plus 2 is 3. So 3x plus 3 equals 42. Subtract 3. 3x equals 39. Divide by 3. X is 13. Now, you can't just say x is 13. You can't just say the number is 13, because how many do I have to find? I have to find 3. So the numbers, x is going to be 13. What's the next one? Remember, I take 13 plus 1, that gives me 14. I take 13 plus 2, that gives me 15. These are my answers. So we've got 13, 14, 15. You can write it that way, or you can write it 13, 14, 15. Okay? Fun times. Okay. I'm going to see this. It says consecutive odd integers, so I don't need those two. Odd, remember, are x plus 2, x plus 4. Remember, odd and even are the same. I need 2 of them, though, only 2. So I need x for my first, and my second is going to be x plus 2. They have a sum. Add those puppies up. 2x plus 2. So 2x plus 2, that's my sum, is the famous equal sign. Whoops, got a little carried away there. 24. Subtract 2, 2x is 22, divide by 2, x is 11. That is not your answer. Sorry about that. We have to find the pair of integers. So I need the numbers are, well, the first one's 11, because that's x. The second one, remember, is x plus 2, so it would be 13. 11 and 13. Boom, 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 boom. You are done.